Good day. I'm Patricia Ludovice, and I'm here to present our study, Estimation of Metal Orange Dye's Molar Absorptivity using a photoresistor-based photometer, with special thanks to my co-author and advisor, Dr. Ramon Santos, for his guidance. The presentation will have the following structure: the background on absorbance of light, teaching absorbance with spectrophotometers and portable photometers will be discussed first. This will be followed by the presentation of the research questions, then the methodology created to investigate the questions. Lastly, the results and discussion will present the findings, and the main takeaways will be articulated in the conclusion and recommendations. A UV spectrophotometer measures absorbance of light given a sample at a continuous or single wavelength. However, issues are found in teaching absorption spectroscopy using commercial spectrophotometers. First, the unavailability of research-grade instruments negatively impact the learning of students. And second, the measurement itself that applies the concepts of light absorption is obscured from the learner. Light absorption can be explained at a molecular level. The incident light I0 excites molecules, and the molecules may go back to their ground state, emitting packets of energy and photons. Thus, when light passes through a sample that hasn't been previously excited, the intensity of transmitted light I at any given narrow band of wavelength is less than the corresponding incident light I0. And the negative logarithm of transmitted light over the incident light is called absorbance. Similarly, absorbance according to Beer-Lambert's law is the product of molar absorptivity epsilon times concentration times path length. To identify the absorbance A of a sample using an instrument, its standard components include a source, wavelength selector, and a detector. Of all the combinations of different sources and detectors for the hand-made photometer created to solve challenges in the lack of instruments as well as black box learning, the simplest and by far accurate design is the one that uses LED as a source and a photoresistor as a detector. Specifically, this is the photometer by Adams McNicol, Shell, and Ellis in 2019. The photoresistor-based photometer by Adams McNicol et al. Is a student-built photometer with component advantages and potential to be transformed to a printed circuit board. On the left is the schematic diagram of the chosen reference photometer that I have adapted and modified for this project. While in the left is the equation developed by the same literature to quantify the absorbance of the solution through reading the voltage across the 10 kilo-ohm resistor. The voltage readings include B sample, or when the cuvette contains dye concentration, B solvent, or when the cuvette has zero dye concentration, and VBET, or the voltage reading across the voltage source. To investigate the photoresistor-based photometer used, methyl orange is chosen. It is a compound that gives intense orange color suitable for dye, stain, and pH indication. The molar absorptivity of MO in distilled water is 14,650 liters per mole per centimeter at 464 nanometers. Moreover, this study banks on the significance of alternative devices when commercial photometers are unavailable, as well as the possible contribution of metal orange in dye-sensitized solar cell technology research, since metal orange is found to be a potential light harvester. Combining the background, literature findings, and significance of the study, the questions of the research are: can the molar absorptivity of metal orange be accurately determined from the absorbance readings of the adapted and modified photometer? And is the method of identifying the molar absorptivity of metal orange repeatable? Now, for the research methodology, the vision for the modified photoresistor-based photometer is to turn this reference layout into this modified layout. The schematic diagram on the right shows the copper coils. These allow temporary replacement of LED for a changeable light source, and the coils will make the voltage reading easier using alligator clip. The construction of the photometer started with the manufacturing of the acrylic PCB holder and painted cover. Then, the modified schematic design is engraved on a copper clamp and the electronic components were soldered. After attaching the 9 volts rechargeable battery using alligator clips and 2 multimeters, one to measure the voltage across the battery and another to measure the voltage across the 10 kilo resistor, the device was completed. It was ready to move to the next stage. Then, for stock solution preparation, about 0.03 grams of MO powder is dissolved in 100 ml distilled water to create 0.001 molars of MO dye solution. Then, the general step for diluting the stock solution to the target amounts are by adding the calculated amount of stock solution into a 100 ml ball flask and then filling the ball flask to mark with distilled water. Repeatability is a measure of precision that estimates the variability in measurements performed by a single analyst using the same equipment over a short period. To measure this, 6 samples of 0 micromolars, 40 micromolars, 45 micromolars, and 50 micromolar concentrations are subjected to absorbance measurements, where each sample is read 5 times. The absorbance is calculated using equation 3. The nominal absorbance and the standard deviation of the absorbance values are calculated. Lastly, the absorbance of each concentration prepared are calculated. Then, an absorbance versus concentration plot was made. The slope of the plot is compared against the literature value of methyl orange dye's molar absorptivity. Now, on to the results and discussion. By the end of the construction phase, the reference photometer implemented on a breadboard is now transferred to a copper-clad and the printed circuit board is made. Next, the repeatability is measured by calculating the standard deviation below. Since these values are considered low, this confirms that measuring the absorbance using the photometer under the same conditions over a short period is a repeatable process. Lastly, the determination of aqueous metal orange dye molar absorptivity is made, and here are the concentration and absorbance. Graphing these values as shown in figure 12, the molar absorptivity of aqueous MO at 460 nanometers is determined from the slope of the basket line. It is 14,861 liters per mole per centimeter. On the other hand, the literature value of aqueous MO dye at 464 nanometers is 14,615 liters per mole per centimeter. Referring to these values only, the percentage error is about 1.44%. The percentage error signifies not just the deviation of the experimental molar absorptivity from the theoretical molar absorptivity value, but also the possible influence of various sources of error. The physical factors that may contribute to the error are the reflection of light from the inner walls of the device and the defects on the plastic event. Visual inspection showed that there are no presence of colloids or suspensions. However, the effects of MO powder and solvent purity in the achievement of the exact molar absorptivity value are noteworthy. The extent of these physical and chemical factors that may have contributed to the sources of error were not explored in this study. Moreover, the research questions are solved, and it is found that 1. The molar absorptivity of methyl orange is determined with the adapted and modified photometer with only about 1.44% error. Then, the method to identify the molar absorptivity of methyl orange solutions is repeatable. Hence, it can be concluded that the modified photoresistor-based photometer can be used for studying absorbance of other solutions, minimize black box investigation, and substitute commercial spectrophotometer. The modified photoresistor-based photometer is recommended to be used in identifying a purified natural dye's molar absorptivity to deepen the device contribution in DSSC research, and in the future, the implementation of the device in educational training, where teachers and students can use it for absorbance studies, is also possible. Here are the references highlighted in this presentation. Thank you for listening, and we are now open to any comments and questions you may have. Thank you so much.